Now you might ask me, and quite rightly so, what does this photograph have to do with you and mathematics? Well, probably not a lot, but if you think about it, it actually has an enormous amount to do with you and mathematics. I've loved the photograph since forever. It's all about attitude, and there's a little dachshund chasing a bull white rhino, and that little dachshund doesn't know that it weighs 5 kilograms and that bull rhino weighs about 3 tons. Young people, I've always liked this slide because it shows you what attitude can do, and this is the attitude that I'd like you to have when you do mathematics. It doesn't matter how small or how big you are, doesn't matter how small or how big mathematics is. This is the attitude that you should have. I might only be small, I might weigh 5 kilograms, but boy, I'm going to give this heaps. The reason why the story has always appealed to me is because I used to work on a game reserve, and I used to go and run in the game reserve with Mrs. Howell. And we had 2 Jack Russells, 2 females, and they used to do exactly that. They weighed 5 kilograms, and they used to chase the rhino. I had a bull and a cow rhino, and we used to have to pick them up eventually because I was worried that the rhino were going to be done an injury. They were going to step in a hole and break a leg and fall, something like that. And my little Jack Russell's very, very tiny, but all heart, big hearts. And that's what I want you to encourage to have. Have a big heart around mathematics. Don't be intimidated by it. If you're unclear about something, ask and get lots and lots and lots of practice. So here we go, young people. Pythagoras. I do hope you enjoy this unit of work, and I do hope you have a lot of fun while you do it. Always look for an element of fun in it. Just a few quick comments to start with. Remember the IXL resources. You've got your passwords. Use that, and I'll refer you to that in class. Don't forget to use YouTube. If you're stuck with anything, go to YouTube, type in Pythagoras. You will be amazed at how much there is on YouTube. Google it. You'll get a million hits. And if you've got textbooks, other textbooks, brothers and sisters from your mum and dad, doesn't matter. They're all useful. They've all got explanations. They all come from different angles, so use those profitably. Just also a reminder that this work is in the beta textbook, pages 312 to 326. Your electronic copies, which you are going to be getting, are possibly different. It's chapter 22 in the beta textbook. Please do find it and see where the equivalent pages are. Also, with Pythagoras, please remember the following. Pythagoras only works for right-angled triangles. The long side, or the hypotenuse, is always opposite to the right angle. The formula for Pythagoras is c squared is equal to a squared plus b squared, c squared being the hypotenuse and a squared and b squared being the short sides. And one can calculate the length of any of the sides if you have the length of 2 of the sides. For your reference, young people, I've included this screenshot of Ultranet, Ariwa College Ultranet, Mathematics, Year 10, Pythagoras. This is what it looks like. This is, I've clicked on the introduction to Pythagoras. You can see there calculating the hypotenuse at the top, calculating shorter sides, calculating either short or the long side, Pythagoras applications, and 3-dimensional Pythagoras, which we are going to do as well. On the right-hand side, there are PowerPoints that relate to those points. We're watching them in class, but they're there for you, young people. Down the left-hand side, learning intentions, success criteria, some references there, Khan Academy, and some IXL references. Young people, you must go into this site, you must use Ultranet, you must know this site better than you know your middle name. You've got to spend plenty of time going into this site and using the resources. Use the PowerPoints. I didn't mention the worksheets below the PowerPoints on the right-hand side. Use those worksheets as extra work, and I'll be referring them to you in class as well. Please become very, very familiar with this site. This is chapter 2, The beginning of the Pythagoras unit, page 312 in the textbook. Have a go at the starter. It's actually a useful exercise, so it goes on to the next slide as well. It's a useful exercise because you are going to be measuring some Pythagoras calculations, and it's actually good to get some practical experience in measuring it before you turn to the all, if I can say, academic side, where you use calculators and calculations. It's good just to have a go at measuring and seeing that the old Pythagoreans actually figured this all out by first measuring it, and you can get a better grasp, a better understanding of how it works. Read through this slide. This is the basic Pythagorean theorem. Hopefully you know it by now. Hopefully you've heard the word and the theorem so often that you've become familiar with it. But have a good read of this because it all sums it up very nicely, very tightly. Exercise 22.01. Please have a go at this, young people. Question 1, all its parts. Question 2, all its parts. The first bit has been done for you. Make absolutely sure that you're able to do this. If you can do these, pretty much you've got the basics all sorted. All you'll need after that is a bit more exercise, and make absolutely sure that you remember to mark your work by going to the answers, and always do get into that habit. It's a very, very good habit. Calculating the hypotenuse. These examples are wonderful for you young people because they do the work, they ask the question, then they give you the answer, they work it out, they show their working, which you must really get into the habit of doing. Show your working out. If you do that, sometimes you make a mistake with the answer, but you get the working part right, then you can still get a merit or an achieved. You might not get an excellence. If you put the answer and the answer is wrong, you can't get anything. So that is very, very good advice. Listen carefully to what I'm saying. Get into the habit of writing your formulas down and showing your working out. It takes a moment extra, but it's a lot of fun and it shows that you know your work. So work through these examples. Be absolutely sure that you're able to use your calculator where needed to find the answers. This is good practice for you for what lies ahead. This is a screenshot of the AlterNet page, calculating the hypotenuse. The previous screenshot was from the textbook, so I've taken the trouble here just to go and show you what the textbook looks like, then to show you what AlterNet looks like, and I'm also going to show you after this, the next slide will be a screenshot of the PowerPoint that relates to calculating the long side. You can see it sitting there on the right hand side. So young people, that sort of covers all the bases. I'm not going to do that every time because you're familiar with the system, but you've got 3 sources: textbook, AlterNet, and also PowerPoints, and there are worksheets down below. Between those we're going to be flat out busy, but having a lot of fun as we go along. So looking at this slide, you can see learning intentions are there, success criteria there, there's some references there for the textbook, and there's some Khan Academies and some worksheets and some YouTube references sitting down there. So please use this system as broadly as it's been given to you. Use all of these resources. Here is the slide from AlterNet from the PowerPoint, how to calculate the long side or the hypotenuse. It's there. It explains how it works. Please do make use of it so that you can understand how to calculate the long side of a right-angled triangle. Exercise 22.02. This is where you put your knowledge of Pythagoras into practice. Asked to calculate the length of the unknown marked side. So please do all of those. They should be reasonably easy, quite doable, and make sure that you mark your work. This is an interesting slide and a bit of extension for you young people. 2 ways to actually prove that Pythagoras works, 2 different ways of proving it. Have a read of that, have a work through, you'll find it interesting, Just shows you how wonderful mathematics is. There's not just one way of doing things, there are normally multiple ways. That's what makes maths such an exciting subject, is there are multiple ways of going about your business, doing your work. As I've said previously, one can use Pythagoras to calculate any side of a right angle triangle as long as you have the other two sides. So this is the way to calculate the shorter side of a right angle triangle using Pythagoras. Have a look at the example on the left, answer on the right. Make sure that you're able to do that yourself, understand what is happening here. It's quite clear, I think. The example is very good. Also remember at this point that there are also alternate resources about calculating the shorter side of a right angle triangle. Remember that you can and should and must go there, use the PowerPoints, click on the main page, get the learning intentions, get the references, and also there are resources. Have a look at those for extra practice. That's very important, young people. Please do use Ultranet as much as you can. It is a very good resource. Exercise 22.03, calculating one of the short sides. Please do all of these exercises, or certainly do all of the examples, all of the questions in there. They shouldn't be too hard, and do remember to mark your work when you're finished. This is practical mathematics, where you use the formula practically, word problems written out in English with clues as to what you need to do, and you have to interpret them. It's a lot of fun to answer these sorts of questions and build your formula around what's being asked, and calculate your answer to fulfill the question. So have a look at these. The next 3 or 4 slides will relate to exercise 22.04, and have a go. Please do questions 1, 3, 5, 7 and 9, and please do remember to mark your work when you're finished. Have a go at questions 3 and 5 on this slide. Do question 7 and have a go at the others if you'd like. Do question 9.